We now return to money on Modern Marvels. We all know money doesn't grow on trees, but it does sprout from, of all things, blue jeans. The discarded scraps from the denim garment manufacturing process are sold by the ton to make the cotton-based paper on which United States currency is printed. This is the facility hungrily buying and stockpiling it. Crane & Company in Dalton, Massachusetts. Since 1879, this family-owned firm has produced all the specialized paper used to make American banknotes.
There's no getting around the fact that the paper in a banknote is much of the mass. It's at least 90% of all the material there. So it's like the crust in a pizza.
Waste cotton comprises about 75% of the material Crane uses to make its banknote paper. The other 25% is waste flax. Paper currency must endure a lot of wear and tear, and paper made from wood pulp couldn't survive the abuse.
The fibers in wood pulp are not as long and not as strong as the fibers in cotton. We have nearly pure, highly crystalline cellulose in cotton, so it's much stronger, more brittle, a rattle in the paper when you move it, a crispness, all those characteristics that make U.S. currency paper so distinct when you feel it.
Achieving that distinctive feel, which counterfeiters find very tricky to duplicate, is the result of a time-honored and painstaking process.
The first job is to remove some of the natural waxes and oils that are associated with the otherwise very pure cotton cellulose fiber. And this and the oils and waxes are generally removed in a pressure cooker, in what we call a rotary boiler.
For 2 hours, 6,000 pounds of cotton in the 15-foot wide boiler cooks in a caustic bath of sodium hydroxide and other chemicals. A conveyor then dumps the steaming shreds into a pulper that breaks down the cotton into smaller fibers. At the same time, water washes away the caustic chemicals still lingering in the material. Another conveyor advances the cotton pulp toward additional washing stages.
This is the final washing stage here. This material will be transferred along this conveyor up into our bleaching stage. We'll take this and we'll make it a whiter material than what it actually is now.
After the bleaching process, we remove the water from the pulp, not 100% dry, but sufficient so that we can stack it on skids and move it around from one place to another, and that's what we stockpile.
Several of the ensuing steps are secret and can't be filmed because they involve adding critical anti-counterfeiting features. Crane will mix red and blue security fibers into the pulp, which will become randomly distributed throughout the paper. It will embed a security thread denoting the bill's value at a precise position within the note. Crane will also incorporate a watermark that varies by denomination, a faint image mirroring the portrait on the bill. The watermark process begins with a pair of bronze dies used to impress a 3D image on a wire mesh.
You can see here are embossed three-dimensional structures in the wire. This is Abe Lincoln, the subject of the watermark for the $5 bill.
The wire mesh is wrapped into the shape of a cylinder that then rotates partially submerged in a tank. The tank holds the paper, now liquefied into a slurry of 96% water. As the wire mesh turns, the pattern of the watermark subtly rearranges the fibers collecting on its surface.
The mesh of the wire is so small that it captures the fibers. So as the fibers are draining, they accumulate in the low areas, they're sloughed off in the raised areas, and the resulting sheet of paper has this reduction in opacity where it's thin, increased opacity where it's thick, held up to the light, It produces that multi-tonal shadow look of a watermark.
Like the watermarks, the security threads play a key role in frustrating counterfeiters. These 3-inch wide rolls are 48 threads wide, and each roll contains enough thread for more than 2.5 million notes. Slitting the roll requires surgical precision, as each of the 48 threads is separated by a space only 1/1500th of an inch wide.
So we have to introduce a plastic strip whose thickness is roughly equal to 1/4 of the thickness of the paper, get it right into the middle, right inside the paper on a continuing basis, thousands and thousands and thousands of miles with no defects.
That's one of the secret processes Crane couldn't allow our modern marbles crew to capture. After that step, further refinements and drying, the nearly finished paper emerges as a roll 16 bills wide. To ready the sheets for printing at a later time, machines then apply a special coating called sizing.
This is an animal glue and chemicals that seals the surface of this paper because it'd be real porous without it, and the ink would just spread through the fiber. They put this surface sizing on it so it prints well.
After the coated paper dries, cutting machines complete the paper's long odyssey, dividing the rolls into sheets bearing the templates of 32 bills. What began as raw cotton is now the world's most durable banknote paper, and a counterfeiter's worst nightmare.
What makes banknote paper really different is to look at it in transmitted light. This is where the primary security features are revealed. We have the watermark of Abe Lincoln in every note, and we have the security thread. And the security thread has the denomination of the note. In this case, it says USA 5. So in transmitted light, these are visible. In reflected light, they're gone. It's a tough assignment for the counterfeiter to produce a feature that fills that bill.
Echoing Tim Crane's analogy, the pizza crust of the banknote is ready for delivery. It'll be up to the Bureau of Engraving and Printing to add the all-important toppings. This kind of assembly line efficiency began changing the face of America's money factories early in the 20th century. At the U.S. Mint, productivity had skyrocketed with the advent of electricity and automation. The same was true at the Bureau of Engraving and Printing. Both agencies were helping to energize the economy of a nation emerging as a global power. Each was now filling production orders from the recently established Federal Reserve. In 1913, President Woodrow Wilson had signed the act creating it, hoping to stabilize America's money and banking system. It provided an elastic currency that could expand and contract in response to the economy's changing demands. The Mint and the BEP are the Treasury Department's currency suppliers to the Federal Reserve. The Fed, as it's called, has 12 districts nationwide that monitor America's money supply. When the amount of cash in a district falls below acceptable levels, the Fed places an order with the Mint and the BEP to make and deliver more money. During the Fed's early years, the money it managed finally began to resemble what we take for granted today. Until the 20th century, no likeness of a president had ever graced an American coin, a tradition inspired by George Washington. Washington had rejected the Mint's plans to use his portrait, wanting no part of a practice exercised by European monarchs.
And it really wasn't until the introduction of the Abraham Lincoln penny in which you saw a president on a coin. Shortly thereafter, you saw other presidents show up on coins as well. You see Thomas Jefferson, and of course we have Franklin Delano Roosevelt, John F. Kennedy on our coins today, and George Washington himself on the quarter.
America's paper currency also got a 20th century facelift. Until 1929, federal banknotes were a ½ inch wider and nearly an 1.5 inches longer than today's. Designing a smaller note enabled more notes to be printed for every turn of the press. The dimensions of our bills haven't changed in 3/4 of a century, but virtually everything else about them has. Making the new generation of currency combines old-school craftsmanship and cutting-edge technology. A new American banknote can be folded forward and backward at least 4,000 times before it tears. Money will return on Modern Marvels.